Good morning, everybody. Today's topic is theories of the catalysis. First is the intermediate compound formation theory of the homogeneous catalysis, and this theory is applicable only for the homogeneous catalysis, in which catalyst first react with one of the reactant and to form an intermediate, and the energy of this intermediate is very high, so it is react with the reactant and undergo the decomposition to regenerate the catalyst in its original composition, and it liberate the product. Now consider the simple example A and the B. These are the two different type of the reactant, and C is the catalyst and AB is the product. So first of all, the C catalyst react with A and to form an AC. This is an intermediate, and this AC is again react with the B, that is the reactant. So it form AB, that is the product, and C is regenerated. So let me moving into the one example, the oxidation of the SO2 to form the SO3 in a lead chamber process. So in which here we use the catalyst as NO. So first of all, this NO, the catalyst react with oxygen and to form the NO2, and this NO2 react with SO2 to form the SO3 and NO. The catalyst is regenerated here. Now we are moving into the adsorption theory of the heterogeneous catalysis. This theory is only applicable to the heterogeneous catalysis, in which the adsorption is the main process in which the reactant molecule is adsorbed on the catalytic surface. The catalyst containing the number of the site where unbalanced or residual force is exist. So this site is known as the active site. So there are three processes occurs in heterogeneous catalysis on the surface of the catalyst. First of all, the reactant molecule is diffused on the surface of the catalyst, and as we increase the concentration of the reactant, this will finally physisorb on the surface of the catalyst. It is shown in the green ball are the reactant, and reactant is diffused towards the surface of the catalyst, and it is first of all it form a physisorption on the active site of the catalytic surface, and similarly the next reactant, a yellow balls, again moving towards the surface of the catalyst, and it will both the reactant are in a proper orientation, so the bond between the atoms is weakened, and to form a bond there is a small the weakened bond is formed in between the two reactant. After the chemical reaction, the molecule is break down from the catalytic surface and escape from the catalytic surface. This entire process is schematically represented in the graphical model that is shown in the top of the slides. First of all, the reactant molecule is diffused towards the surface of the catalyst, and this molecule is physisorpted on the surface of the catalytic surface in the active site. Then the bond between the reactant just weaken, and finally the bond break, and there is a weak bond is formed between the other reactant, and finally this bond strengthen and to form the product, and after the chemical reaction the product is escaped from the catalytic surface, and it is diffused in the solution. This is the entire process which is taking place in adsorption theory of the heterogeneous catalysis. Now we are moving into the one example, the hydrogenation mechanism, hydrogenation of the ethylene, in which we can see that there are the two reactant, ethylene and hydrogen. Here we use the catalyst as the nickel. So nickel is a solid. In the solid surface of the nickel there are lot of active site are there, in which the bond is and there is an unbalanced force is existing. That's why a bond the reactant molecule, that is hydrogen and ethylene, is diffused on the surface of the catalyst, and as the concentration on the surface of the catalyst increases, the bond between the hydrogen and hydrogen, it is slowly weakened, and the reactant, the atom, the hydrogen, is very close to the ethylene molecule, so it form they are in bonding distance. That's why the hydrogen is make a bond with the carbon in the ethylene and to form the CH3, and that part is liberated from the surface of the catalyst. Similarly, the next hydrogen is react with the carbon of the next carbon in the ethylene molecule, and finally it forms a bond CH3. After the formation of the bond, the molecule become ethane, and the reaction is completed, so this molecule escaped from the surface of the catalyst. And now the adsorption theory of the heterogeneous catalysis can be the efficiency of the reaction can be increased by dividing, or if you are using the finely divided metal as the catalyst. And this reaction, as we discussed earlier, the catalytic reaction is highly specific, and specific type of the catalyst is only active for this type of the reaction. And the action of promoters, the presence of some material increases the catalytic activity of the catalyst. Similarly, some of the material, that is known as catalytic poison, due to their presence, the activity of the catalyst is reduced. Thank you.